So hello everyone, welcome you all to this new video. So in my previous videos, I have discussed two important scheduling techniques. That is, one is preemptive scheduling or SJF scheduling, and in the next video, I have discussed with the round robin scheduling. So those two scheduling techniques with one important example, I've discussed it with you all. That I had made separate videos. Those who have not watched it, it would be available in the channel. Please go and watch those videos, guys. So we have one more kind of scheduling left here. That is priority based scheduling. Okay, so this is again one important scheduling technique where we are going to do the scheduling based on the priorities. Okay, the priorities they would be mentioning in the question, so based on those priorities the scheduling is done. Okay, so let us see this now, how this would be working. Same as that of the non-preemptive priority based scheduling, except for the switching of execution in between the tasks. Okay, it is same as that of the non-preemptive scheduling. In preemptive priority based scheduling, any high priority process entering the ready queue is immediately scheduled for execution, whereas non-preemptive scheduling is a high priority process entering the ready queue. It is scheduled only after the currently executing process. Okay, so the priority based scheduling, they would be giving you one priority, but based on the priority, it should be executing the complete process. After that, only the next part of the scheduling is done. Okay, so that is one important difference noted down in this priority scheduling. It completes its execution and or only when it is voluntarily released from the CPU. Okay, the priority of the task or process in preemptive priority based scheduling is indicated in the same way as that of the mechanisms and adapted for the non preemptive multitask. Okay, so let us see this with one example, how this priority based scheduling works. So this is the question they have given here. Okay, three processes with process IDs again P1, P2, P3 with estimated completion time of 10, 5, and 7 milliseconds, and they have given the priorities, that is 1, 3, and 2, where in the bracket they have mentioned it as 0 as the highest priority and 3 as the lowest priority. Okay, so they have given it in the reverse manner, that is the lowest number has the highest priority and the highest number has the lowest priority. Okay, it respectively enters the ready queue together, that is these three process IDs would be entering the ready queue together. A new process P4 with the completion time of 6 milliseconds and priority as 0, they have mentioned it as 0. So since the priority is 0, it should be the highest priority. Okay, enters the ready queue after 5 milliseconds of start of execution of P1. Okay, so the completion time for this P4 is 6 milliseconds and it would be entering after 5 milliseconds. Okay, after start of execution of P1. Assume all the processes contain only CPU operation and no IO operations are involved. Okay, so this is the pattern. So based on this pattern, let us try to analyze this figure here. Okay, so you see here at the beginning there are only three processes, that is P1, P2, P3 available in the ready queue, and the scheduler picks up the process with the highest priority. Okay, that is in this example P1 with priority 1. Okay, for example, you see here highest priority is, in this example it is P1 for scheduling. Why it is highest priority? Because in the bracket they have mentioned it as 0 as the highest priority and 3 as the lowest priority, right? But they have given the priorities for P1, P2, P3 as 1, 3, 2. Okay, they have not mentioned 0, but after 0 the highest priority is 1, right? So that's why P1 would be selected. So that's why P1 is selected for scheduling. Now process P4 with estimated execution time of 6 millisecond and priority 0 enters the ready queue after 5 milliseconds of execution of P1. Okay, so the processes are rescheduled for execution in the following order. You see here, first at the beginning P1 is selected since it has the highest priority 1. Okay, so 1 0 P1 is selected, so that's why it would be executing up to 5 milliseconds, because after 5 milliseconds we should be P1 would be preempted, because the next highest priority is P4, that would be entering because it has the highest priority as mentioned, that is 0. So after 5 milliseconds P4 would be entering, and its completion time, that is estimated completion time, is 6 milliseconds. That is after 6 milliseconds, that is 5 plus 6 is 11 milliseconds. So at 11 milliseconds P4 would be completed. Again you see here the total completion time for P1, they have mentioned it as 10 milliseconds here, you see here. Okay, but in the question they have mentioned after 5 P4 would be entering. So now again P1 is again in order to complete it required still more 5 seconds, because it has taken already 5 milliseconds. The remaining time now 10 minus 5 is 5 milliseconds. So now again still more 5 are remaining, so that's why it takes again 5 milliseconds. That is 11 plus 5, 16. Okay, so now completely P1 would be completed. All the 10 milliseconds of P1 is completed. Now next is P3, because you see here the priority, based on the priority, P3's priority is 2, right? So since they have given in the bracket 0 as the highest and 3 as the lowest, so after 1, the next we should be considering 2. Okay, so that's why P3 is selected, and it would be completing its time up to 7 milliseconds. So that's why 16 plus 7 and 23. Next, after P3, the next priority is, since P1 is completed, P3 is completed, so now P2 is remaining for 5 milliseconds. So that would be taking its time and completing. That is 23 plus 5, 28. So the total completion time for all these things, they would be taking 28 milliseconds. Okay. So hope it is clear how this preemptive or the priority based scheduling works. So it is very easy, guys, if you understand. Okay. First, P1 would be entering, since it has the highest priority 1. So it would be executing for 5 milliseconds, because they have mentioned in the question after 5 milliseconds P4 would be entering. Why P4 would be entering? Because in the question again they have mentioned it as P4's priority is 0, which is the highest one. So that would be entering, and it would be having the completion time of 6 milliseconds. So it would be taking 6 milliseconds to complete. Again, after 6 milliseconds, since P1 has completed 5 milliseconds, it has remained with 5 milliseconds. So that would be taking place, and totally P1 would be completed. Then P3 would be completed. Why P3 is selected? Because it has the next highest priority, that is 2. So it would be taking 7 milliseconds to complete. Then after that, P2 would be remaining. So it would be taking 5 milliseconds. Okay, so like that this diagram goes, and this figure would be representing that flow of execution. Okay, so hope you understood this. So now let us again discuss with the waiting time, average time, turnaround time, and average turnaround time. So the this is very easy. Waiting time for P1, that is 0 plus 11 minus 5, that is 0 plus 6 milliseconds. So P1 initially it would be 0, then 11 minus 5, since it should be waiting for this many time to complete, right? So since P4 is getting executed here, so that's why 11 minus 5 it should be waiting for 6 milliseconds to be completed. Similarly for P4, it is 0 milliseconds. Why? Because you see here initially it was 0. It should not it need not be waiting any waiting time, because it has the highest priority. So since it has the highest priority, it would be executing first. So that's why it should not be waiting at all. Okay, next is waiting time for P3. For P3 it is 16 milliseconds. Why? Because you see here, in order to complete P1, P4, and P1, after these things only the P3 would be executing, right? So that's why it should be waiting for 16 milliseconds. Similarly for P2, since it is 23 milliseconds, because the total time taken for P1, P4, P1, and P3 to completely execute, it would be waiting for 23 milliseconds. Okay, so that's why these are the waiting times for P1, P2, P3, and P4. That is 6, 23, 6, 23, 16, and 0. Okay, so now take the average of that, that is 6 plus 0 plus 16 plus 23 divided by 4. So the answer is 11.25 milliseconds. Turnaround time, again the formula remains the same, time spent in ready queue plus execution time. So for P1 it is 16 milliseconds. So in ready queue it has spent 11 millisecond, and the execution time for uh, P1 is 10 milliseconds. So 10 plus 6 is 16 millisecond. Similarly for P4 it is 6, for P3 it is 23, and for P2 it is 28. Okay, so now take the average, that is 16 plus 6 plus 23 plus 28 divided by 4. Our answer we would be getting it as 18.25 millisecond. Okay, so this was completely about priority based scheduling. Okay, so hope you understood this. It is very easy if you understand, listen to the video correctly from start till end, you would be understanding this priority based scheduling. So why I did these three scheduling techniques? Because in these three, any one of them, it is a sure shot, you mark my words, any one of them would be definitely asking for the exams. Okay, so that's why I thought to do this video, different videos for different scheduling techniques. So I have covered all the three scheduling techniques. Those who have not watched the previous two, go and watch it. And this was it for the priority based scheduling. And hope you understood this. Thanks for watching till here. So that's all for this video, guys. Okay. So like, share, subscribe to the channel. Keep supporting. Thank you.